Assalamualaikum. I am Nufara Shira binti Cik Basri. I will be presenting the problem-based learning PBL under the course EAT251 Structural Theory. I am from Group 3 and this is our group members. For introduction, on 1st January 2021, Dr. Nid Zainab, who is the lecturer of EAT251 Structural Theory, has given us a task which is Problem-Based Learning (PBL). The course outcome CO3 of Problem-Based Learning is to able to calculate the internal forces in cable and arch, while the program outcome PO2 is the ability to identify, formulate, and solve complex engineering problems. In this task, it requires us to solve a problem as stated in the question, which is the difficulty of the villagers to do their everyday chores when the boat that being used to connect Tanjung Surat Island and Belungku Jetty have their own schedule. In order to solve the problem, we as an engineer have to design the bridge to make a land transportation between Tanjung Surat Island and Belungku Jetty. This is the bridge design in 3D, while this is in 2D. We have chosen an arch bridge as our design bridge. An arch bridge is a bridge with abutments at each end shaped as a curved arch. Arch bridges work by transferring the weight of the bridge and is loaded partially into a horizontal truss restrained by the abutments at either side. A viaduct, a long bridge, may be made from a series of arches, although other more economical structures are typically used today. Arch can be used to reduce the bending moments in long-span structures. Essentially, an arch acts as an inverted cable, so it receives its load mainly in compression, although because of its rigidity, it must also resist some bending and shear depending on how it is loaded and shaped. If the arch has a parabolic shape and it is subjected to a uniform horizontally distributed vertical load, then from the analysis of cables, it follows that only compressive forces will be resisted by the arch. Under these conditions, the arch shape is called a funicular arch because no bending or shear forces occur within it. For the design concept, the bridge that we have designed for this task is an arch bridge. We take the bridge references from Rocky Creek Bridge in California in order to design our bridge in this task. Rocky Creek Bridge is a reinforced concrete open straddle arch bridge on the Big Sur coast of California, built in 1932. The reason why we take Rocky Creek Bridge as our reference in designing our bridge is because it is an arch bridge. There are a few advantages of using an arch bridge as our design bridge. The first advantage of using an arch bridge as our design is it can span a greater distance when using the arch design for a bridge. Secondly, there is a higher level of resistance available with an arch bridge. The curvature of the arch bridge design gives the deck and overall structure more strength and alternative options can provide. Furthermore, arches adapt to the local environment better than other designs. In addition, we use reinforcement concrete as our main material in the making of this bridge. Reinforced concrete in which steel is embedded in such a manner that the two materials act together in resisting forces. The reinforcing steel such as rods, bars, or mesh will absorb the tensile, shear, and sometimes the compressive stresses in a concrete structure. As the term reinforced suggests, reinforced concrete provides extra strength. With greater comprehensive strength than regular concrete, it is able to hold more weight over more time. Reinforced concrete also tends to have a long service life with relatively low maintenance and in turn low maintenance costs. It is strong and durable, requiring little repair or replacement, making it often the most economical choice. There are several factors that will influence longevity, including the method of reinforcement.
Assalamu alaikum. This is Abdullah Ataf from Group G3. This is the bridge design from 2D view. And this is the bridge design from isometric view. I took the bridge design ideas from a real-life bridge in the United States of America. All data and measurements are listed on the figure. All the assumptions purposes are mentioned on the reported. That's it from my part. Thank you.
So next we go to the grinder costing part. First, we look for the grinder or beams. Material cost can be calculated easily for the rectangular beam. First, calculate the value of the material needed by multiplying the cross-section area by the length of the beam. Next, the cost of the material depends on the material chosen. We will use steel, so we need to convert our volume to kilogram. Then calculate the total cost per beam by multiplying the volume of the material by the cost of the material. So we have the beam cross section area is 300 meter square, and then we have beam length which is 100 meter, so we get 3000 meter cube. So cost for one steel or concrete is 15,000, so the total cost will be 10,000 for one beam. So we have two beam, the total cost is 35,000. Next is the column part. Material can be also be calculated for the columns. Each of our column will have a length of 100 mm. Then we calculate the volume of the material needed by multiplying the cross section area by the column length. So we have the cross section area of 300 meter square, column length is 100 meter, so we have 3000 meter cube. So the total cost for 6 column will be 75,000. Next, we have the calculate for the foundation and soil investigation. So for this one, we will have the cost for the foundation is 150,000 for the foundation, and also for the site investigation we will do 2, so the total cost will be 100,000. Next, we need to hire the design engineer and field engineer, which is 100 ringgit for design engineer for 1 hour, and field engineer for 80 ringgit for 1 hour. So the total cost they work for 3 months for designer engineer is 48,000, and field engineer for 9 months is 115,200. For overall cost for beam is 35,000, column is 75,000, foundation is 100,000, and cost for engineering is 163,200. So the total cost will be total cost estimation is 373,200. That's all for my part. Thank you.
Hi, I'm Koi Zheng, and today I'm going to present the calculation part for our PBL. First, we need to assume the load acting on the bridge. We assume the load of 8 kN per meter is uniformly transmitted to the arc ribs. This is the diagram for our bridge, and as you can see, we have divided it into 3 parts: part 1, part 2, and part 3. Since the arc has a parabolic shape and is subjected to a uniform horizontally distributed vertical load, then from the analysis of cables, it follows that only compressive forces will be resisted by the arc. Under these conditions, the arc shape is called a funicular arc because no bending or shear forces occur within it. For part 1, after we apply the equations of equilibrium, we found out that Cy equals to 400 kN, Ay equals to 400 kN, and Ax equals to Cx. Then we divide this part into 2 parts at section B. This is the diagram for arc segment BC. After applying the equations of equilibrium, we found out that Cx equals to 370.37 kN, Bx equals to 370.37 kN, and since Ax equals to Cx, Ax equals to 370.37 kN, and By equals to 0. Then for part 2, after applying the equations of equilibrium, we found out that dy equals to 0 and dx equals to negative 370.37 kilonewton, which is 370.37 kilonewton to the left, opposite to the direction we assume in the free body diagram. For part 3, since the two parts are symmetrical and the loads acting on both parts are the same, Ex equals to negative 370.37 kilonewton, which is 370.37 kilonewton to the right, acting in the opposite direction which we assume. Ey equals to 0. That's all for the calculation part. Thank you.
As for the conclusion, from this project, we can conclude that both course outcome CO3 and program outcome PO2 are achieved. The bridge that we have been designing absolutely can solve the villagers' problem. With this bridge, the villagers do not have to suffer anymore because of the scalded boat. Moreover, this project also helps us understand more about the complex problem solving. This complex problem solving have covered our depth-specific knowledge and thinking skill in order to solve the problem. As an engineer, this ability to overcome such a problem are really needed so that we can be a better engineer that can help more people in the future.